Alright, today we're going to be learning about medians and altitudes. So far, we've talked about mid-segments that go from midpoint to midpoint. We've talked about perpendicular bisectors of triangles. We've talked about angle bisectors of triangles, and now we got two more different segments to talk about. So, let's get to it. The first thing you need to know is a median. The definition of a median is a segment that goes from a vertex. So again, vertex of a triangle, you always have three of them. They're your 3 points of the triangle. Goes from the vertex to the midpoint of the opposite side. So vertex to midpoint, vertex to midpoint, vertex to midpoint. So that's what a median is. Okay, now don't write the definition in your composition book. Here we have the concurrency of medians of a triangle theorem. Again, concurrent means they're intersecting at the same point. This point is called the centroid. What this theorem tells us is that they intersect at a point that is 2/3 of the distance from each side to the midpoint of the opposite side. And actually, we should say from each, vertex here. So change this one to vertex. So it's 2/3 of the distance from the vertex to the opposite side. So point P is 2/3 of the way. If you're going from B to F, B to P is 2/3, which would mean PF is 1/3 of that segment. Okay, so the key is 2/3 from the vertex to your centroid. So, using that information, we know that G is our centroid because it's where all the medians intersect. Again, medians go from vertex to midpoint. It says if DG is 14, then what is AG? Well, from here to here is 2/3. Okay? We said this is 1/3. Well, if you think about it, 2/3 is twice as big as 1/3. So if we multiply this by 2, we would get 28. So AG is 28. Okay, so that's kind of another way of thinking about this, is that this longer piece will be twice as big as the shorter one. 1/3 versus 2/3. If BE is 39, so if this whole thing is 39, then what is BG? Well, BG is 1/3, so you take 39 times 1/3, which is the same as dividing it by 3, and you're going to get 13. So again, remember, from the vertex to the centroid is 2/3, okay, which means the rest there is 1/3 of that whole segment. Next type of segment we call an altitude. An altitude of a triangle, it's the perpendicular segment from a vertex to the opposite side, or the line that contains the opposite side. So this is an altitude. It goes from a vertex that makes a right angle at the opposite side. Now, an altitude could also be outside a triangle, because if you want to draw the altitude from A, well, BC is the opposite side. Clearly, you can't draw a segment from A to BC that would be perpendicular. So BC gets extended out in order to draw that altitude. So this altitude actually lies outside the triangle. The altitude from C would also lie outside the triangle. You would have to extend this one and make a 90 right here. Okay, so only 2 of the altitudes are shown in that picture. Concurrency of altitudes of a triangle theorem. All this one says is that your altitudes are concurrent. Okay? All your altitudes meet at the same point. So you have an altitude from point B, point C, and point, looks like I lost a point there maybe. So AF, I'm missing point A, that's what it is. So this would be point A here. So here's an altitude here, goes from B to the opposite side. And we got an altitude here. So again, we say all those altitudes meet at one point. This point's called the orthocenter. All right, next example says determine if segment BD is an angle bisector, perpendicular bisector, median and or altitude, given the information. So it says BD is perpendicular to AC. So we know this. And we know that AD and DC are congruent. So now, we're going to want to take it piece by piece. So, is BD an angle bisector? Might be tempting to say no, there's not enough information. However, if these two are the same, we do have reflexive property here. And we have side angle side congruence, which means our corresponding parts would be congruent. So it's an angle bisector. Then we got to decide if it's a perpendicular bisector. Oh, clearly it is. Got a right angle, those two are the same. So it's a perpendicular bisector. Median goes from a vertex to a midpoint. So it's a median as well. And is it an altitude? Altitude goes from a vertex to make a 90, so yes, it's actually all four on this one. All right, some more examples. It says point G is a centroid. So again, centroid is where your medians meet. It says GE is 2x minus 2. So this would be 2x minus 2 here. And then BE is 5x plus 3. So the whole thing from B to E is 5x plus 3. We're supposed to solve for x. So you got to think, okay, obviously GE and BE, they don't equal. But we do know that EG is going to be 1/3 of BE. So we can say that 2x minus 2 equals 1/3 of, which means multiplication, 5x plus 3. Now you could distribute your 1/3, but then you're going to have to work with a decimal. Or you can multiply both sides of your equation by 3. So if I multiply this side by 3, I'm going to get 6x minus 6. If I multiply this side by 3, well, 3 times a third is 1. So that goes away, and we're left with 5x plus 3. So we just multiplied the smaller one by 3, essentially. Subtract 5x over, add the 6, and x is 9. If you want, you can check it. Plug in 9. This would be 18 minus 2 is 16. This would be 48. And 16 times 3 is 48, so it works out. 2. Copy and complete each statement for triangle DEF with medians DH, EJ, and FG. Gotta be helpful to draw a picture. So here's our triangle. My weird looking triangle. So triangle DEF. So our medians DH. We point H here. Then we have EJ. And then FG. So it says EK. So K is our centroid, I should label that. It says EK equals blank KJ. Well, KJ is 1/3, EK is 2/3. So EK is equal to 2 times KJ. GK compared to FG. FG is the whole thing. GK is that smaller part. It's 1/3 of FG. And then DH to DK. So dH is the whole thing. dk is 2/3 of it. But you don't want to do 2/3 of dk equals dH. That would be wrong. But we do know that if you flip it, 2/3 of the big one, which is dH, equals dk. So if we want to solve for dH, we're going to multiply both sides by the reciprocal, 3/2. So you multiply by the reciprocal, well, 2's cancel, 3's cancel. So dH equals 3/2 of dk. So you also have a few problems like that. So again, remember that rule with your centroid is 2/3 of the way to that midpoint. So B to G is 2/3 of BE. D to G is 2/3 of DF, and so on. So the main two topics for today are altitudes and medians. And there's your assignment. That was a sneeze.